We have three new exciting spacecraft that are launching into space on Tuesday, including NOAA's new space weather satellite. Joining me now to talk about the overview of why this is so important and critical for forecasting and seeing space weather impacts hitting us here on Earth is Dr. James Spann, a NOAA Senior Scientist for space weather. Thank you so much for joining me today.
Well, thank you. It's my privilege to be able to share about this exciting missions.
Yeah, so Dr. Spann, this is not just one mission. It's three separate entities going up at once. Can you tell us more big picture about what these different tools are that are being launched into space?
Sure. So this is going to be a cosmic carpool since the three of us are going together. The primary mission is IMAP, a NASA mission that is going to look at the interface of our solar system with interstellar space. The second mission is another NASA mission called Carruthers, and it's going to sit far away from the Earth and look back at the Earth to observe the very extended atmosphere of the Earth, called the exosphere. And then finally, the NOAA Space Weather Follow-On mission, which I'm associated with, is going to be looking at the sun 24/7, making very robust and trustworthy observations of the sun so that we can generate warnings and alerts to help protect life and property here on the Earth and protect our astronauts and other space assets in space.
So let's talk more about that mission that is going to be, that you're really involved with, looking specifically at the sun. For people who just see this bright thing in the sky, why is the sun so important, and what does it send our way that we have to monitor every minute of the day?
Sure. Well, the sun is important. I mean, obviously it powers the planet with energy, but it also is not just a very quiescent ball of gas that's sitting out there, 93 million miles away. It is very, very active, and occasionally it does have these very violent eruptions, solar flares, or coronal mass ejections, where a lot of mass of the sun is actually ejected. And if it comes and strikes our Earth, it energizes our magnetic field and creates solar storms that impact technologies that we rely on every day.
And of course, we're in one of those active phases of the solar cycle right now. So we've seen here in Georgia 2 instances in the last year seeing the aurora borealis. But of course, it looks pretty in the sky. But as you mentioned, there can be impacts if they hit the right way and if it's strong enough. Can you talk to me more about how this instrument will help us get a clearer warning of the impacts we could expect?
Yes. And so we are going to be looking at the sun with 4 instruments. 3 of the instruments look at the solar wind, which is the charged particles and the plasma that come off the sun all the time. And the other instrument is going to be imaging the sun, its extended atmosphere. And by imaging the extended atmosphere, we can tell when one of these very large explosions take place. And it usually takes 2 to 3 days to get here. Then once it comes in our environment, the other 3 instruments will measure very specifically the density and the velocity and the magnetic fields associated with it. And that, having all of that information in real time with very direct contact down to the Earth, we can generate the warnings and alerts that will help the power grid know if they need to readjust how they send out the power through the various systems they have. Airline industries, especially if they're doing transpolar flights, they may want to adjust those flights because of the additional radiation that the crew and passengers might get. And then satellite operators, they need to understand whether they need to safe their spacecraft. And then there are communication issues that are impacted, both for airlines as well as regular communication and geopositioning systems like GPS. All of these things are affected. So having a heads up that something is coming is very important for all of these systems to be ready.
Yeah, so critical, so critical. Let me ask further down the line. Is this also something that might help us as we head into the next missions of sending man and woman to the moon, the Artemis missions that are getting ready to launch? How can this provide clearer and closer warning for them as well to make sure they're protected?
Oh, absolutely. And so NASA and NOAA are working very closely together on this issue, where as NASA prepares to send humans to the moon and eventually onto Mars, and who knows where we're going to end up, but we're going to go a lot of different places. And so understanding that environment and understanding the impacts in space are extremely important in order to safeguard our astronauts and even our spacecraft as well. So working together, being able to forecast that environment, particularly for humans, it's the radiation environment. So understanding when an occurrence on the sun occurs and how long it's going to take to get here, and the intensity and the nature of that radiation storm is all of what we're working together in order to safeguard the astronauts, as well as, like I said, other assets, other spacecraft that are already out there.
And you must be so excited as a scientist who studies the sun every single day. When is this going to be operational? When are you going to first get your first new visuals looking at the sun?
So we're going to launch now, and then we're going to have, it'll take a couple of months to get to where we're going. As we're going there, we're still beginning to check out instruments and everything, but it won't become operational for several months, even after we get there, at least for the NOAA part, because we have to check, make sure everything, we understand exactly that the data is giving exactly what we expect and understand it. And so it's going to be several months before we get there, maybe April timeframe. So that's when we'll start seeing the first light, as they call it.
Such excitement in the world of space weather. Dr. James Spann, NOAA Senior Scientist for Space Weather, thank you so much for joining us today.
Well, thank you. It's been my privilege. And the fact is that I enjoy doing this very much, and then they pay me to get to do it. So that's how much.
Isn't that a wonderful thing to be a scientist and get to do what you love?
Hey, it doesn't get much better than this.
Thank you so much. Have a great day.
All right. Bye-bye.